Hi there, Edison people out there. My name is Brian Bates. I'm going to show you. I am not good at very good at writing and reading and all that stuff. So I thought a video, not video diary, a video comprehension of what I can do would be a lot easier to understand. What I've done is there are bonds, chemical bonds that hold molecules together. I've done one step farther than those ones. What I've done is I've learned that each molecule, each atom is millions and millions of years old or whatever, and they all come from the sun. You gotta remember that atoms come from the sun. So in other words, the sun produces a hydrogen atom. You take that one, fuse it with, say, another one, boom, you got helium, right? Helium, and then you, boom, fuse it together again. So you have one helium atom, one hydrogen atom, fuse those two together, boom, you got lithium. All I've done is each atom that is fused together, it has an electrical current running through it. It's DC, a negative charge, and it has a positive charge. So what I've done is if you look at this drawing here, okay, this here, sorry, this here is an electric generator. As you can see, you make an electrical current through that, and then the negative is the embouchure, and the positive is the thing that spins. And the positive is connected to a steel plate, and the negative is just a negative wire. That's a carbon dioxide molecule. It's a Covalent bond or whatever. It has 3 bonds, but it looks like an ionic bond. Anyway, this is carbon and the 2 oxygen atoms, and they're fused together by a bond. So you take this, you pass it through. You pass it through what we call an electrical field. It breaks them. It breaks the carbon away from the, as you can see here. It breaks the oxygen atom away from the carbon atoms. So you got carbon atoms floating, oxygen atoms floating. Now with a steel plate, because steel contains carbon in it, the plate absorbs the carbon, and then just because there's no oxygen in the steel plate, the oxygen is basically fused with the air around it, because it has oxygen, atmospheric air. So you have a bunch of electrons, and what they do is they're flying in a million miles an hour, or the speed of light squared or whatever. And they hit the bond. The bond breaks, and hence that's what you get. This. See, water, you would have a hydrogen atom and then 2 oxygen atoms, right? All these basically show, this thing here shows exactly what an engine does. Like, okay, so you have an engine, you have the fuel line and the gas tank, catalytic converter, tailpipe, muffler, blah. So right about here, if you stick an object like cotton with an electrical charge between here and there, and then as the exhaust, like the fuel goes into the engine, combusts, as the exhaust goes through, right about here, where you have the electrical impulse thing, it's cotton with gasoline. The same gasoline that's in your tank. It takes the exhaust, breaks it into two things. You have like gases, and then you have fuel. You take that fuel, and you put it back in the gas tank, and it goes through again. So it does a complete circuit. All this is the same thing. Fuel, air, the whole 9 yards. But basically, these are pictures that I've drawn over the years. What is this? See? Steel molecule. And carbon atom bonds with the steel, blah, blah, blah. It's the same thing. They're just drawings. But it's prized possession. But this is what it is. This is what all the theory is and stuff like that. I will post some pictures on it so you can actually see what it is and how it works and stuff. Oh, my eyes are... things like that. What else can I tell you about? Basically, like everybody says, oh, you can't make this, you can't do that. Over 1,000 years, lots of years, they are trying to figure out how to make lead into gold. Well, that's easy. Just take away one proton. What is it on the chart? I think it's 2 protons and 2 electrons. You take them away, and lead is gold. If you take them 2 away, change the weight of the object. So you have 2 extra electrons and protons. So if you use, say, lead to gold, take the atoms or not atoms, electrons and the protons away, you will get another object. So if you give them to lead will turn into something else. Sorry, I don't have the periodic table of elements in front of me, but as you can see or hear, kind of figure out what I'm talking about. If you have an open mind and you have a theory on elements and how they interact and all this stuff, and it's you probably would know. There's physics called quantum mechanics, and it tells you all about this stuff and how the math works and everything else. Let me see here. I'm thinking. So theoretically speaking, it would be about years ahead of quantum mechanics. Years ahead. How things are formed. Basically, what I'm talking about is how things are formed. Like, per se, you have a diamond. Everybody has a diamond. They have chips. They have like carat. They're measured in carats and things like that. I am not prepared to do this, but this is cool. Anyway, okay. So, say you take a diamond of 1 carat. Over okay, say 6 months. You take the diamond, you put an electrical current around the diamond, or to the diamond. You put a positive charge to the diamond, and then you have a box. You put a diamond in it, and you put a positive charge to the diamond, and then you have a negative charge because DC current is run on 2. And you just put it in the box. You don't connect it to the diamond. You just let it whatever. And then as air passes through the box, okay, so you have 2 holes. So as air passes through the box, it'll take the carbon out of the air, put it in the diamond. But see, now the diamond has a molecular structure that's different than a normal carbon atom. But it will change. And it'll bond itself to the diamond, hence make it bigger. What I'm doing is what nature has done over millions and millions and millions of years. I'm duplicating that and doing it in a matter of seconds. The formula for anything, basically, to make oil, to change climate, fix climate change, to toxic chemicals, to anything, is volts times amperage. Okay, say for climate change, so it would be volts times amperage divided by whatever the atmosphere is, parts per million, divide that by parts per million. So say it's 410. So it would be V times A divided by 410 parts per million equals the time it would take to basically fix it, to absorb all the carbon. Okay, so you have a 12-volt battery. Oh God, I haven't wrote it down. I haven't got the numbers. Say 120 volts and 1,000 amps is 12,500 divided by, say, 400 is give or take, say, 25,000. So it would take about 25,000 seconds to do a room that had 410 per million. So if you had 1 million air cells and 410 of them were carbon dioxide, it would take about less than 20 minutes. Take 2 minutes, sorry. It would take roughly about 2 minutes to 5 minutes to complete it. So if you had a room full of air and say 50%, you had a 24 by 24 by 24 foot room, and half of it was carbon dioxide. It would probably take, say, 25. 25, we'll make it easy. 25 by 25 is 625 times 25 is, anyway. Okay, roughly saying, say you had an area of 32,000 square feet of air. Boiled down to is, say, 300 and say 50,000 square inches of air, like say 300,000 square inches of air, and half of it was carbon dioxide, which means 150, roughly 150, 3 is 5. So 50 minutes, it would clear the air, make it pure. 50 minutes, roughly, give or take. I haven't figured out the numbers or anything like that. But if you want more information on this or whatever, I can try to write to you. It probably might make sense, might not make sense, I don't know. But I will try to answer your questions. If you email me at brianbates.1. My email address, is all lowercase, Brian Bates, BRYAN BATES 1 at live.com, and I'll get back to you. Noises itchy. But I hope you do vote me through to the next round. I don't know how exactly it works, but we'll wait and see. But I might have something. But I just need a scientist, a climatologist, some astrophysicist, an astronomer. You put 4 of those people together in a room, and I guarantee you we'll have an answer for you. And I appreciate any back information that you have or anything like that. But please vote for me. Thank you very much, and we'll talk to you later. Bye-bye.